Good morning to all of you and welcome to all of you in my new video. And today in my new video we shall discuss about the new topic. But this topic is not new for you because you have already studied this topic in class 11th, limit and differentiability and limit and derivative. So here we shall discuss the differentiability of the function at any point. So, in class 11, we know that the differentiability of any function at any point, let f be a real valued function and a be any point in its domain, then the derivative of f at x equal to a is defined as f dash a or ddx of y at x equal to a is defined as f dash a equal to limit h tending to 0 f a plus h minus f a divided by h, provided this limit exists finitely. If this limit exists finitely, then the derivative of that function must be exist at that point. Or we can say in general, the derivative of y with respect to x is also denoted by limit delta x tending to 0 delta y by delta x, and this must be equal to limit delta x tending to 0 and the value of delta y is fx plus delta x minus fx divided by delta x, and this formula is also known as the differentiation by the first principle, and this is it means this is the change in for y equal to fx. X is independent variable, y is dependent variable. So delta y is change in small change in dependent variable with respect to change in independent variable. So the ratio of this change in dependent variable with respect to independent variable, but limit delta x tending to 0 means instantaneous change in dependent variable with respect to independent variable is defined as the derivative of that function with respect to the given independent variable. So limit x tending to 0, in this formula delta x divided by h, so we will get the result limit h tending to 0 delta y by delta x, limit h tending to 0 similar x plus delta x minus fx divided by h, provided this limit must be exist finitely. It means that function, it means the derivative of that function must be exist at that point. Now question is arise that what is the meaning of the derivative? So I would like to discuss its a geometrical interpretation. I am taking a function y equal to fx is a function. This is a function y equal to fx, and p is any point on the function whose coordinate x and y. So this distance is x and this distance is y, and q is any other point near to p whose coordinates x plus delta x and y plus delta y. So if there is a small change in the variable x, there is a small change in independent variable, so dependent variable also changes. So there is a small change in dependent variable is delta y. So subtracting this, value of delta y is fx plus delta x minus fx. It is just like this, the value of delta y. So there is a small change in dependent variable. Now in that question, this is x, this is x plus delta x, this is y, this whole y plus delta y. So this is also y, so this is delta y. If we are taking the triangle is PRQ, so tangent of means tan phi of that is equal to delta y by delta x. So this is equal to change in dependent variable with respect to independent variable. So this is delta y by delta x if taking delta x is tending to 0, delta x is tending, this is the delta x. If this value is tending to 0, then q tending to p. As delta x is tending to 0, q tending to p. If q tending to p, it means this intersecting line become a tangent. So this tangent line, it means we can say limit delta x is tending to 0 tan phi equal to limit delta x is tending to 0 delta y by delta x. So delta x is tending to 0 tan phi, it means this is the limiting value of this. So this become changing to intersecond line, or you can say the second line converted into the tangent line. So the derivative of, suppose at that time the inclination of tangent line is psi, so tan psi is equal to the limit delta x is tending to 0 delta y by delta x, and this must be equal to ddx of y. So the meaning is that the derivative, first derivative or derivative of a function at any point represent the slope of tangent tan psi. In class 11 we have already discussed that the slope of tangent is given by m equal to tan theta, where theta is the inclination of that line. Here psi is the inclination of tangent line, phi is the inclination of second line, and psi is the inclination of tangent line. So tan psi equal to dy by dx, and this value is known as first principle. By the first principle, this value equal to ddx of y, or we can say the first derivative of the function y. So it means the dy by dx means ddx of y represent the slope of tangent at that point. So slope of tangent at that point. Is that clear? Now, one more condition is also arrived in that question or in that definition. Sometimes function is defined for greater than a and less than a. So how we to check that function is differentiable at that point? So due to which we have to check both the derivatives as well as left hand derivative of the function and the right hand derivative of the function. We have to check the left hand derivative of the function and right hand derivative of the function. So now how can we check the left and the right hand derivative of the function? And we have already told you that in class 11 also, the dd means first derivative of any function denotes the slope of tangent at that point. So right hand derivative of the function is denoted by limit h is tending to 0 plus f of a plus h minus f of a divided by h, and left hand derivative of function at x equal to a is defined at limit h is tending to 0 minus f of a plus h minus f of a divided by h, provided both limits must be exist finitely and equal, then the function is differentiable at that point, otherwise function is not differentiable at that point. And we have already discussed some important result about to find out the derivative of function, or we can say algebra of derivative. So what is the algebra of derivative? Algebra of derivative. We have already first डेरिवेटिव ऑफ एफ प्लस माइनस जी इज इक्वल टू डेरिवेटिव ऑफ एफ प्लस माइनस डेरिवेटिव ऑफ जी. Similar, derivative of product of two functions f into g. All of you know that first function and derivative of second plus second function and derivative of first. So this is the algebra of derivative. One more condition is also called division, because we know that in algebra plus minus multiplication and division. So derivative of fx by gx or f by g is denoted by g square, means denominator square, g into derivative of numerator, means denominator into derivative of numerator, minus numerator into derivative of denominator. These formulae we have already discussed in class 11th also, so these are the most important for your for upcoming questions. So you have to learn these formulae. Now we shall discuss two most important theorems, and theorem is that first theorem is that if a function is differentiable at any point, then it is also continuous at that point. This is the theorem number 1, and theorem number 1 is that if f is differentiable at x equal to a, then it is continuous at x equal to a. मीन्स अगर कोई फंक्शन ऐसा है जो किसी पॉइंट पर डिफरेंशियल है, तो हम आंख बंद करके कह देंगे कि वो कंटीन्यूअस भी होगा. लेकिन कन्वर्स इज नॉट, नीड नॉट बी ट्रू, मे बी ट्रू. कन्वर्स मीन्स अगर कोई फंक्शन कंटीन्यूअस है तो हम ये नहीं कह सकते कि वो डिफरेंशियल भी होगा. हो भी सकता है और नहीं हो सकता है. सो आई एम गोइंग टू डिस्कस द प्रूफ ऑफ दैट थ्योरम. लेट f is differentiable at x equal to a. It means, what is the meaning of this? Its derivative will exist. So limit h is tending to 0, f of a plus h minus f of a divided by h. Now I am going to find out the value of fx minus f. So this can be written as fx minus f divided by x minus a into x minus a. मैंने क्या किया, हम इसकी वैल्यू निकालते हैं. x माइनस a से डिवाइड किया, मल्टीप्लाई किया. fx माइनस f taking the limit x tending to a. Or we can say that f dash equal to also written as x is tending to a. So fx minus fa divided by x minus a. This is also the value of derivative of function at any point. If you are putting x equal to a plus h, then you will get the previous result. H is tending to 0. F a plus h minus f divided by h. If you are putting x equal to a plus h, so both are there. There is no need to change. So don't be confused with that. Limit x is tending to a, fx minus fa divided by x minus. So into limit x is tending to a, x minus a. Now this limit is the derivative of the function, so this is f dash a into this limit is 0. So limit x is tending to a fx, और इसमें x है नहीं तो इस पे लिमिट का कोई इफेक्ट होगा नहीं. minus f a equal to 0, or we can say that limit x tending to a fx equal to f. It means the meaning of that limiting value of the function is equal to the exact value of the function at that point. Hence, this is the definition of continuity. अगर limiting value equal to the exact value, it means the function is continuous at that point. Hence, f is continuous at x equal to a. Is that clear? So फंक्शन हमारा कैसे, हम आपको ये लेके चले थे कि फंक्शन इज डिफरेंशियल एट x equal to a, then it is a continuous at x equal to a. Now we have to discuss its converse of this theorem. So what is the converse of this theorem? Converse means every differential function is continuous, but every continuous function may not be differential. Every differential function is continuous. So I am taking theorem 2. What is the theorem 2? Converse of theorem 1 need not be 2. So I am taking one example and check. Example is that I am taking example of that function which is continuous at any point. We will show that the function is not differentiable at this point. So I am taking a function y equal to fx equal to mod x. Modulus function, all of you know that x and minus x, its value x greater than 0 or x less than 0, or we can say equal to 0 पर value कितनी हो जाएगी 0. This is the definition of modulus function, and we know that this function by the graph we have already discussed that the modulus function is always continuous. By the graph it is clear that this is y axis, this is x axis, and the graph of modulus function this is the graph of modulus function, and that is the continuous. So we know that f is continuous at x equal to 0. Now I would like to check the differentiability of that function at x equal to 0. So first I would like to find out right hand derivative at x equal to 0. So limit h tending to 0 plus h minus f of 0 divided by h. Don't forget here 0 plus means h is greater than 0. For the greater than 0 function is x. So value of f is h. So this is limit h is tending to 0 plus h minus 0 by h. So this is 1. So this limit is 1. Now to find out its left hand limit of the function, not limit, left hand derivative of the function, limit h is tending to 0 minus f of 0 plus h minus f of 0 divided by h. It means limit h is tending to 0 minus h 0 minus means less than 0. For less than 0 function is minus h. So f h minus h minus 0 divided by h. So this is minus 1. It means, what is the meaning of this? First derivative is 1, second derivative is minus 1. Or what is the meaning of derivative? meaning of derivative is slope of tangent. First slope means 1 is 45 degree. Minus 1, 135 degree. So there are two tangent at x equal to 0. So due to which function is not differentiable. क्यों? उस पॉइंट पर हमको कितने टेंजेंट मिल रहे हैं? 2. जबकि मैंने आपको बताया था डेरिवेटिव मींस स्लोप ऑफ टेंजेंट. यहाँ पर स्लोप ऑफ टेंजेंट कितने मिल रहे हैं? 2. और कोई भी फंक्शन किसी पॉइंट पर तब डिफरेंशियल होता है जब उस पॉइंट पर फंक्शन केवल एक ही टेंजेंट ड्रॉ कर सके. यहाँ पर कितने टेंजेंट ड्रॉ हो रहे हैं? 2. इट मींस एट x इक्वल टू 0 फंक्शन इज नॉट function is not differentiable. So therefore at x equal to 0 f is not differentiable. So this is the example of that function which is continuous but not differentiable. So it means every continuous function is not differentiable, may be differentiable but not every time. So this is the next theorem. So in my next video we shall discuss some different types of how to find out the derivative of some different types of functions. So thank you all for watching this video. Thank you.